Hello, I'm Paul,
And I'm Julia.
and today we'll be talking about the AIDE Onshape team, what we've been doing this semester, and what our future work will entail.
So AIDE Onshape is responsible for 3D modeling Claire's unit process components in the browser-based CAD software Onshape and integrating them into the Claire infrastructure design engine, or AIDE, which will allow anyone with an online computer to generate an accurate Claire plant model. We work on making our models as accurate, configurable, standardized, and efficient as possible. Part studios are where new parts are created in Onshape, but sometimes it's necessary to bring in a part from another part studio. Variables are not transferred when regularly deriving a part from one part studio to another. The tool Derive, made in FeatureScript, allows for variables from the derived part to be referenced in the rest of the part studio. As shown in the image, we can also set prefixes. This makes it easier to connect parts together and manipulate models from code side. One of the benefits of Derive is that it can cut down on the number of configurations used. In the assemblies, we had transferred over basically every single configuration that each part studio used into the assemblies configuration. This resulted in assemblies with hundreds of configurations, leaving an unorganized mess of configurations. With Derive, configurations of the derived part studio can still be altered based on other configurations as seen on the figure on the left. This semester, we are implementing the 3-level design into Claire's main unit processes. The build feature, or the BF, instantiates entire unit processes all together using user inputs to give the specifications of the plant. The hydraulic design feature, or the HDF, receives input data from the BF and converts user input into geometric variables. These variables are used in the design part studio, or the DPS, to create the customized geometry. The reason AIDE is moving to implement 3-level design is to decrease runtimes and to avoid the crashes that we would face once we started putting the main unit processes together, as well as make it easier for all users to create a plant. Pipeline is a FeatureScript feature that was developed to make the creation of pipes much simpler. Prior to this, in order to create a path of pipes, we would have to drive in individual pipes, elbows, tees, etc. With Pipeline, you can just create a sketch of the path of the pipe, use the Pipeline feature, and click lines and vertices as appropriate, and pipes will automatically generate. Clicking on just a vertex with just one line attached will generate a pipe, while a vertex with 2 lines in line with each other will generate a couple, and 2 lines and a vertex forming a 90-degree angle will generate a 90-degree elbow. At the end of October, the AIDE team started to notice a lot of issues with Pipeline. Some of the issues are that Pipeline is slow for large file sizes. This means that a lot of our main functions were taking a long time to load. It's hard and tedious to create well-documented functions in Pipeline. It is also hard to test functions across different documents. Additionally, it is hard to control the type of part we imported. For example, if we want to create an elbow fitting by selecting 2 lines, but they are connected to a 3rd line as shown in the image, Pipeline will automatically generate a T fitting instead of an elbow. Dimensions sometimes don't line up or are completely incorrect with our main source of pipe dimensions, as Paul will show in the live demo now.
Okay, so now a live demo. So I want to kind of show why improving the Pipeline tool is important. So to that end, let's take a look at one of our part studios, the multi-tank sedimentor input-output, aka SED-IO-N for short. The SED-IO manages the input and output flow to the SED tank from this front face. So naturally, it has a lot of pipes and fittings to carry this flow. And this gives us a good reason to use the pipeline tool, which makes it far easier to create strings of pipes. So we can create this outlet pipe far more easily by simply selecting 2 lines plus a vertice in between, which will create 2 pipes plus an elbow to connect them. Furthermore, we can control the size of these pipes using configurations using pipeline. So for example, I'll set the nominal diameter of this pipe from 6 to 8. So after a moment, the geometry will be updated. There you go. However, while pipeline is good at making pipes, couplings, elbows, T's, and crosses, their dimensions aren't always correct. For example, we've imported standard elbow dimensions to try and make this elbow and this top face of the IO line up, but clearly that's not happening. That's because the dimensions of this pipeline elbow don't match standard elbow dimensions. Also, there's no quick way to get the dimensions from this pipeline elbow. We would have to measure them manually and then tell Onshape what they are. Another example of this is how in red you can see that the elbow is intersecting with this concrete in the IO. And that's because the elbow diameter that we've imported, that we've told Onshape from standard elbow dimensions, does not match up with what this pipeline elbow uses. Furthermore, there are some fittings that pipeline simply can't create, like these valves on the rear end of the set IO. So from this, hopefully it's clear that pipeline has a lot of potential. So we want to work out some of the issues that it has so we can use it effectively in the future, especially when we start working on unit processes that have a lot more pipes, for example, the CDC and the filter.
So there have been some errors with the HV flocculator, which we have been working on fixing. We added the baffles throughout the entirety of all the channels. The last couple of baffles in the last channel had to be deleted, and the last baffle also had to be a bottom baffle for every channel except the last channel. We had to correct the positions of the exit slots across each channel. There were also some errors in the tank concrete itself. Additionally, we are adding pipe spacers and washers between each baffle to keep all of the baffles in the correct position. We will continue working on the HV flocculator.
This semester, Monroe has been helping out a lot with modeling the one tank sedimentor and its main component, the sed tank. But we also want to have a model of the multi-tank sedimentor or the sedimentor N that has several sed tanks. The main components of this are 1, the sed tank, and 2, the multi-tank sedimentor input-output, which again is abbreviated as sed-ION, which connects to the sed tank on its front face. It's highlighted in green here. Our work on the sed-ION included making sure that the correct variables were constraining the design and that they were constraining it in the proper way, as well as adding piping to the rear of the sed-IO, as well as fittings to connect to other components, as well as preliminary testing to make sure that the connections between the sed-ION and the sed tank were fitting together properly. The next main task for AIDE Onshape is to work with Ethan Keller to complete an improved version of the pipeline tool. Our team's role will primarily be populating a database with standard pipe fitting dimensions that pipeline will pull from. Once finished, we'll work with Ethan to iron out any remaining bugs in the code. Other than that, we'll continue to change the way of working in 3-level design. So for example, currently we instantiate variables called expert inputs and then enable them to be overridden by creating several individual variable features and then importing them all. This works, but it means that we need to repeat the same code in 3 places. So we plan to make this process happen more efficiently by using FeatureScript to create a single list of these variables to be directly imported into the build feature and the hydraulic design function code. That's kind of complicated. So to try to understand that a little bit better, currently what we do is we make variables like this entrance L using individual features. And then in order to make sure everything works properly, we need to copy that verbatim 2 times elsewhere, right? And that makes things a bit complicated or prone to breaking. So what we want to do is we want to convert this feature into FeatureScript code, which will be written once and then imported twice, which just streamlines the whole process of writing out all these expert input variables. Lastly, once the HV Flocculator and the Sedimentor make use of the new pipeline tool, we plan to move on to implementing 3-level design in the CDC and then the rest of the plan. So that's all we have. Thank you for your attention. And please let us know if you have any questions or recommendations. Also, please see our appendix slides if you'd like to see any of the documents that we've gone through during this presentation. Thank you.